Okay. So for today, I mean, it's quite late, so I'll probably only do it for an hour or so. Yeah. What have I been doing? I've been oh yeah, today I like went to the beach and stuff and like all those kind of things to wrap up before I did like my shopping, so I don't have to do shopping when I move. I'll be moving tomorrow, so it's Kernel stuff tomorrow. What a good amount of time. It's actually not as bad as what I thought it would be. Um, yeah, let's see. Hopefully I can get a TPU today. Sometimes I can't get TPUs. Yikes, I think I'm not going to be able to get a TPU. It's a little annoying. I don't know why on this time zone I can never get a TPU. Oh, what if I request the expensive TPU? Doesn't seem like it's okay. I'm just gonna worry about functionality then for now. So we'll just use the GPU. L4 should be fine. Yeah, I won't be able to get the full TPU kernel functionality, but that's okay. At the very least, I'll be able to code. Okay, so the biggest thing is like kind of like approach I was doing this wrong, right? Um, yeah, so like this approach was incorrect because I need to keep consistent chunk sizes on all sides, including the other thing. What does that mean? Ah, okay. Ah, okay. Yeah, it means ah, I'm frustrated. Yeah, first the runtime got disconnected. In the eyes of the kernel, and in the eyes of like Jack's touch it. Oops, not here. And So we'll have what? Chunk size equals 128 for now. Let's just say nice and square. Number of all chunks is gonna be in we got max. I just run that. Max of group sizes. 4 divided by all chunk size plus okay. Yeah. And now we need to grade across this as well. So it's the big thing. Grid equals 2 E F over F chunk size. Um, and also number of all chunks. Okay, so now I need to take lambda I j k, and this is also going to be swapped around. So put that letters. Really okay with me. So these are okay now, and these are all still I. Right? No. I is it's not j. Yeah, the weight matrix is just j0 k, right? Because we don't care about the d dimension. But lastly, this all is now I comma 0. So we are sharding like that. Offsets and group sizes. I think it. Ideally, we only care about our own offset and group size, right? I think we can keep that as 0 for now. But all right. It's now chunk size changed. Okay, that's interesting. So it means we have these very small chunks of this, right? And Haikia concatenation is like on that angle. All chunk size. Wait, no. What I'm doing doesn't make like it's ragged, right? No, but because of the expert, it's fine. Because it's expert, it's fine, right? Yeah, we know we don't actually want a chunk there. Kind of hazy, but I think I'm seeing it. So we have the offset, right? We know the offset is. We also know which expert it is. We know which xref we're looking at. No, yeah, that's the weird part. It's like we're gridding, but like, will we need to reshape it? The sorted array. So yeah, we sharded by expert, right? But really, expert sharding is for the weights. That's completely separate. Um, yeah, because we don't have the matrix in this shape. This actual ragged shape, right? We don't have it in that shape. So how do we like pretend we have it in that shape? Like really what we have it is like this. Boom, 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 boom. Something like this, right? And we want to say like, and maybe like even there's like some like double lines, like right, like it's zero literally. I want to say like everything from this on, we're gonna loop here, and we're gonna do this. We're gonna do this, or else we can do this, and then just like mask it out, right? Because that's like all fine and dandy, but we run into the problem of these are. I actually don't know what's the problem here. We can't just like create like shards like this, like or chunks like this. We can't just chunk like evenly. We have to find the offset, just do like a. No, I don't like that strategy at all. It needs to be parallelizable, even within the chunk. It's like considered a very simple idea of like two experts here, like this, right? What do I do with the offsets? I use the offsets to raggedify. Even like this case, right? Where it's like more even like this. What I want to do is I want to just divide this into like chunks of this size, right? And then like for this one, we have this, and we have like some overhang, right? And we just like ignore that. It's fine. Um, but that's like two axes. That requires reshaping the array. Capabilities. Is it something I want to do? It does seem like the cleanest way of solving. Problem with like that kind of arrangement. It's like what are we doing there? Yeah, reshaping seems like the best option. Just like getting doubts, but I think it's fine. Just have to keep track of a lot of stuff. Okay, so we reshape. Must be another. I really dislike the idea of reshaping and using padding. I really dislike it. Because we have the offsets. Why are we passing in the offsets then if we're doing all this nonsense? This doesn't make sense. At least, at the very least, this doesn't make sense because it's not going to be chunk size. Yeah, if you just start it directly, it's going to be something else entirely. Approach it from a different perspective. Yeah, there's going to be something else entirely. The raggedness is the issue here. I can get the offset based on the index. It's this idea is like worse than doing padded, like just like directly. Literally worse. I'm gonna go to the bathroom. I'm gonna come back. Testing. I gotta get back to work. Let's continue. Where were we? Alright, it's this deal. Figuring out how do I chunk this? I wanna look at it from the other perspective. Like okay, so this is obviously like completely like not nonsensical. Completely nonsensical. So I think what we do is we make the grid. Why am I doing this here? And then we don't actually do anything here. Lambda ijk 0, 0. Okay, that's the first. No. Maybe I'll go to bed. Able to connect. So let's close this. This is fine. This is fine. Yeah. Do we do this without sharding this with this? Now the basic idea is we want to do a read. Okay. All indexes p out of program ID x is equals 1. X per index is x equals 0, 1. Need this size. Yes. This is important. And ID of 1, ID of 2 equals 0. We want YRF. Now, um, no. At the very least, we can do something like that. Um, So take the index, get the offset, get the size. YRF of All it means is you need to just be somewhat careful about out of balance. Out of balance is the key. Like I could be referencing things that are completely out of bounds. But the other issue is like even if it's not completely out of bounds, right? Okay, I need to construct a valid indices close to desired indices to and p dot this offset plus all index times all chunk size, right? That's the basic idea. Desired indices plus this plus GMP dot a range chunk all chunk size. Okay. Valid indices equals to GMP dot where desired indices is less than this offset plus this size. This indices can't do zero. I could do some like dummy value, but what is like lengths need to match, right? This is like a mask. Yeah? Okay, okay. I'll load. Okay. It's offset plus all checking size. Hmm. This offset plus rf dot store. Desired indices, comma, as equals to valid indices. It's like that. Um, like this, right? Yeah. So you store zeros there, just in case. Okay. This x equals to load. Yo, is there not documentation? Okay. Don't understand. Where do I specify the other stuff? Yeah, the DS. Okay, that's fine. Um, PLS store, wire mask equals to valid indices. Yeah, this x equals to x. Load x, right? Desired indices on this p mask equals to valid indices. Other is to zero. So I believe that, yeah, we don't have any bias, so it should be fine. So it essentially loads the things we want. Now we have to add it to there. It's a little bit of a conundrum. I think it's okay. So I equals to PL load y ref this y plus equals to. I don't know if this is going to be atomic. We may have a race condition here, which is not acceptable. That's not. That's not gonna. Hmm. I'm not using trident. Shouldn't they have the same issue? No, but they don't have the same issue because they just do plus equals. Right, I was about to mess up big. I need to accumulate. Yeah, I can do that. That's a non-issue. I still need to figure out how to do the addition. Yeah, I don't. No, I do. I do. And let me fix the ordering. I realized I made a huge mistake. The actual value. God, that's a lot. I'm just like making things up, to be honest. Advantageous for it. You can just reuse it, I guess, yeah. Yeah. We don't even need all this nonsense. We can literally like verbatim. Do a value. By this. Wait a little bit. Boom, boom. Okay. Yeah. Basically this, right? This is how we get the like activation, right? Output. This is like the gated embed. How's that? Now we just need to do another ragged dot. And so all that is this. Did I delete my this X reference? Okay, okay. This is the this X. Okay, I can load it. Very much is close. It's fine. It's fine. Just leave it at this. We'll figure it out. It's like this X. Um, so we have all these as zeros. I don't need an intermediate three at all. This one too. Now we synchronize, get this to be the activation times this. And after we've synced, now we need to do another accumulation, right? This time we only set x enter 2. Looks good to me, right? Okay. Of dot 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 s equals 2. 1 of dot 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 at wait no but we've have we lost the plot? No, we're so good, yeah. This is how you do synchronization. Now I know. I'm not gonna do the debugging. Progress. Could just be me. I feel like this is really good progress. Now it's Why? It's just yeah, just that. Okay, the last thing is I need to have yeah, that's fine. Yeah, the last thing is I need to have accounting for the intermediate stuff. So how to do that? Scratch shapes. Um, I'm just gonna use VMem as well here. Wait, hold on. Okay, hold on. Oh, those are just raw multiplications. Wait, what? Wait, what? Not contracting on D at all. So the first multiplication can be performed with. Okay, okay, okay. Here's the first multiplication. Can instead end up like with something like this. This is the same size as the. Size. Two of them. One of them is gonna be the size of the. The other one is gonna be size. All size. Mama. Not even on TP, so I can't even test it. I'm just gonna call it. It's been a good